I continue to read the book Genesis, the story of how everything began by Gildor Tonelli. This is the first chapter. In the beginning was the void. The young astronomer focused her studies on the stars with a variable luminosity belonging to the small Magellanic Cloud, a nebula which at the time was thought to be part of our own galaxy. It was Leavitt's incisive observation that the brightest stars were also those with the largest position period. Once this correlation was established, an estimate of the absolute brightness of a star could be obtained, which in turn would allow us to measure its distance from us. The brightness of the object varies according to the inverse square of the distance from the observer. So by knowing its absolute brightness, one need only measure the apparent brightness to calculate the distance. Leavitt measured the relations between luminosity and the period in the Cepheid variables of the small Magellanic Cloud, and by hypothesizing that the stars were largely at the same distance, she was able to construct a scale of intrinsic luminosity starting from the visible ones recorded on the plates. Thanks to the incredible intuition of this brilliant young astronomer, we have at our disposal standard candles, that is to say, light sources of a known intensity, through which it is possible to deduce an absolute measure of distance. This is what Hubble did when he used the surface of the Andromeda Nebula to reach the conclusion that these celestial bodies are too far away to be part of our Milky Way. Lemaitre was familiar with the first measurements made by Hubble, which not only placed these nebulae beyond our galaxy, but also endured them with an impressive speed of recession. His theory of expanding universe made it possible to explain these unprecedented observations, as long as it was accepted that an enormous system was involved, immensely bigger than anything previously supposed. A gigantic structure in which there are countless galaxies similar to our own, with everything inclined to move away from everything else. After having placed the Earth at the center of the universe for thousands of years, and having reluctantly accepted that it is just one of the many bodies that rotate around the sun, a further final illusion suddenly crumbles. The solar system and our beloved Milky Way have no special position. We are an insignificant component of an anonymous galaxy, just one among the myriad of others to be found throughout the universe. And as if this was not enough, the entire system changes over time. Like all material object, it had a point of origin, and it will in all probability also have an end. The Big Bang. Lemaitre's intuition, confirmed by Hubble's measurements, provided the basis for nothing less than a new vision of the world. In his original article, written in French, the astronomer priest had gone so far as to predict a relationship of a strict proportionality between distance and the speed at which astronomical objects recede. If his idea about the expanding universe was right, the more distant galaxies would have to move away from us at higher speeds and would consequently exhibit a greater red shift. And this is precisely the result that Hubble obtained as his catalog of observations grew in complexity and richness. But for a long time, Lemaitre's intuition was ignored because the Belgian journal in which he had published his article had such a limited circulation. For this reason, until very recently, the scientific world had always referred to this correlation as Hubble's law. Thanks to a careful work of reconstruction, the contribution of the Belgian scientist has finally been recognized. It took almost a century, but today the relation that made it possible to establish the essentially dynamic nature of the universe is called appropriately the Hubble-Lemaitre law. In the early 1930s, faced with large amounts of experimental data, Einstein also ended up abandoning his initial skepticism. Legend would have us believe that when reluctantly admitting that the Belgian priest and the American astronomer were right, the eminent scientist regretted his previous failure to understand, remarking that the cosmological constant had proved to be the biggest blunder I have made in my life. Starting from an initial state in rapid expansion, there was no need to introduce this ad hoc correction. And so the cosmological constant disappeared for many decades from the fundamental equation of cosmology. By irony of sorts, however, there would be a further reversal in the second half of the 20th century when the discovery of dark energy caused a term that had so tormented its inventor to be reintroduced. It was Lemaitre, once more, who was the first to speculate that the expansion of the universe could actually be accelerating, and who, not by chance, kept Einstein's cosmological constant in the equation, albeit reduced to a much lower value. Lemaitre described the birth of the universe as a process that had taken place sometime between 10 and 20 billion years ago, starting from an elementary state which he called the primeval atom. His hypothesis drew together the most advanced scientific theories of the period and the numerous mythological narratives that made everything originate from a kind of a cosmic egg. But before doing so, he established the connection between macrocosm and macrocosm that would prove so very fruitful in the coming decades. From the outside, the formulation of this groundbreaking theory produced a great deal of perplexity. In truth, world opinion was otherwise engaged. The Wall Street crash of 1929, the emergence of fascism and Nazism in Europe, the many indications that the entire planet was about to descend into another global war. But even in scientific contexts where there was interest, the skepticism directed at the new cosmological theory was extremely strong. A good number of the most eminent scientists of the age refused even to countenance the idea of a beginning to space-time or a birth of the universe. The problem lay in the fact that it bore a terrible resemblance to the biblical Genesis and to the creation theory advocated by many religions. And if this wasn't bad enough, the first proponent of the theory happened to be a priest as well as a scientist, and a Roman Catholic one at that. The idea of an eternal universe, of an uncreated and everlasting stationary state, had first been supported by Aristotle, and it still fascinated many scientists. One of the best known of these was Fred Hoyle, a British astronomer who simply considered the theory proposed by Lemaitre to be utterly repugnant. Hoyle remained convinced by his own ideas right up until his death in 2001. In 1949, in a program made for BBC Radio, it was Hoyle who coined the term Big Bang, a description he intended as a derogatory. Ironically, the image of a great explosion that Hoyle had used with the intention of ridiculing the new cosmological theory ended up penetrating so deeply into the collective imagination that it contributed significantly to its success. One of the bastions of the most tenacious opposition of the theory was provided by Soviet science. For decades, Soviet scientists stigmatized the Big Bang as a pseudoscientific and idealistic theory that hypothesized a form of creationism far too similar to the religious kind not to be deeply suspect. It mattered little for them that Lemaitre had scrupulously separated the science from faith, to the extent of reacting with horror when, in 1951, Pope Pius XII could not resist the temptation of referring to the Big Bang, described by scientists as resembling the biblical moment of creation. It was an attempt by the Pope to provide a sort of a scientific basis for creationism, to reinforce the rational basis of faith, and Lemaitre strongly objected to it. Let me stop here for this episode.